Hey everyone, and welcome to This Explainer. I am absolutely thrilled to have you here today, especially all of our civil engineering professionals. Whether you're a student, a fresh site engineer just starting out, or a seasoned QA/QC manager, you already know that placing concrete is a massive, critical site activity. But here's the hard truth. Your concrete quality depends just as much on the mold as it does on the mix. If your shuttering is weak, or even just a little loose, your perfect concrete mix is instantly compromised. We're talking slurry leakage, honeycombing, wrong dimensions, and ultimately, flat-out client rejection. So today, we are going to master the exact step-by-step workflow for checking shuttering and formwork before that pour even begins.
Okay, let's dive into this. Here is our chronological site inspection workflow. We'll be quickly covering 1. Basics and technical authority. 2. Geometrical checks. 3. Integrity checks. 4. Pre-pour preparations. 5. Active pour and de-shuttering, and finishing up with 6. Common mistakes and our final checklist. All right, let's kick things off with Section 1, Basics and Technical Authority. Basically, why we check formwork.
So what exactly are we doing when we do formwork checking? By definition, it's the process of verifying that your temporary mold, the formwork, is correctly aligned, properly supported, clean, tight, safe, and actually ready to receive concrete. And listen, this isn't just a casual walk-around glance. If we fail to check this properly, it leads to disastrous cement slurry leakage, massive honeycombing, severe dimensional errors, and client rejection. The formwork is literally what gives the concrete its shape, its line, its level, and its final finish. Simply put, if the mold fails, the concrete fails.
I really want you to burn this simple equation into your memory. Concrete quality equals a good mix plus proper formwork. You can have the absolute best ready-mix concrete arriving on site, but a weak mold will ruin the whole shebang. We are talking about concrete bulging out, incredibly expensive rework, and severe safety risks for the workers on site. Good concrete quality always starts with good formwork. Now, what's really interesting about this slide is that our authority to approve formwork doesn't come from a gut feeling or guesswork. Your final formwork approval must follow the latest approved drawings, your project specifications, method statements, your QAP, and client instructions. And crucially, it has to follow Indian standards. We rely heavily on IS 456-2000, specifically Section 11 for stability and stripping time, along with IS 14687 for false work guidelines. You've got to stick strictly to the approved documents.
Moving right along to Phase 1, Geometrical checks. This is all about the physical shape of the members.
We tackle this systematically on-site in 4 specific steps. First, verify you actually have the latest approved drawing in your hand and confirm the exact location of the member, whether it's a footing, a column, a chaja, or a plinth beam. Second, grab your measuring tape and physically verify the clear dimensions, length, breadth, depth, and thickness. A wrong member size right now causes immediate structural issues down the line. Third, check the line and level using a level instrument, a line dory, or a laser level for things like your beam bottoms and slab levels. Fourth, confirm verticality and plumb. If you were checking a column, well, actually, if it's a column, a lift wall, or a retaining wall, you absolutely must use a plumb bob. A column that is out of plumb creates a massive cascading alignment and finishing headache for the entire building structure. Okay, Phase 2, Integrity checks.
Let's break down these structural integrity checks. First up, check all your joints, corners, and stop ends. Any tiny gaps must be sealed totally tight. Loose joints cause cement slurry leakage, and that is the #1 cause of honeycombing and weak concrete edges. Second, thoroughly inspect your props, bracing, tie rods, and clamps. The entire system has to be rigidly cross-braced. Third, and I can't stress this enough, verify the prop base. Props must never, ever rest directly on weak soil, loose debris, or uneven bricks. They need proper sole plates. If the ground support is uneven, those props will settle during the pour. And boom, you've got a sagging slab. Finally, inspect the shuttering material itself. No bent steel plates, no highly damaged plywood, and definitely no cracked props for critical work. Next up, Phase 3, Pre-pour preparations.
Look, the difference between dirty, dry formwork and clean, properly oiled formwork is literally night and day for your final concrete surface. Before you even think about placing the steel, you have to remove all the dust, binding wire, and loose mud. Then, you apply an approved shuttering oil uniformly, just a thin layer. Dirty formwork completely ruins the finish, but on the flip side, slathering on excess oil will totally ruin your bonding for plastering later on. It's a delicate balance. So the crucial point here is this final rapid-fire checklist right before the QA/QC engineer actually signs the pour card. Have you checked for all your embedded items, MEP sleeves, and puddle flanges? Missing a sleeve now means aggressively hacking into hardened concrete later, which nobody wants. Have you checked the cover block clearance to make sure the formwork isn't pressing directly against your reinforcement? Is there proper access for placing the concrete and getting the needle vibrator in there? Poor vibrator access practically guarantees honeycombing. Are your safety platforms, scaffolding, and barricading rock solid? And finally, if you're doing a stage pour, is the stop end or construction joint perfectly secured?
Moving into Section 5, Active Pour and De-Shuttering Guidelines.
Please remember, your job doesn't end when the pump starts. During the active pour, a site engineer must constantly monitor the formwork. You are watching like a hawk for sudden slurry leakage, bulging under the pump's heavy pressure, prop settlement, or any loosening of those tie rods. You also have to make sure the workers aren't just dumping and overloading one specific area with concrete, because that can cause a massive blowout. Now, regarding de-shuttering, and I want to be very firm about this, there is absolutely no single fixed de-shuttering time for all works. You can't just guess. De-shuttering strictly depends on IS 456 guidelines, the span of the member, the concrete strength achieved, the type of cement used, and the direct, explicit instruction of your structural engineer. Premature de-shuttering is a massive risk. It causes severe structural deflection and cracking.
Finally, Section 6, Common Site Mistakes and our final checklist.
And this brilliantly illustrates the frequent site errors that happen when we are just rushing to get the job done. Using old drawing revisions, that's mistake number 1. Placing props directly on loose soil is a total recipe for settlement. Pouring without adequate cross-bracing will lead to formwork failure, for sure. Trying to save a few bucks with heavily damaged shuttering material just ruins the finish. Disturbing those cover blocks destroys your reinforcement protection. And of course, removing formwork too early is structurally downright dangerous.
Let's look at this final practical checklist. This is the ultimate site engineer takeaway right here, so feel free to take a screenshot of this. Your workflow is neatly divided into 3 stages. Before the pour, check the latest drawings, ensure joint tightness, maintain absolute cleanliness, apply a thin coat of shuttering oil, and verify all safety access. During the pour, actively monitor for any leakage, bulging, or prop settlement, and keep a carpenter team on standby for emergency tightening. After the pour, start your curing process properly and strictly wait for the correct, engineer-approved de-shuttering time. Remember, a top-tier site engineer doesn't just check the steel, they rigorously check the mold holding it all together. So, before we wrap up, I want to leave you with a question. Are you still treating formwork as just a temporary wooden box? Or are you ready to treat it as the absolute foundation of your concrete's quality? If you found this workflow explainer helpful, we actually have a highly detailed shuttering and formwork checking PDF ready and waiting for you. You can grab it right now over on our Telegram channel. The Telegram link is right down there in the description, or you can find it in the pinned comment. If you have any specific doubts about site checking or these IS codes, drop a comment below and IBG InAI will reply to you. Thank you so much for hanging out and learning with us today by IBG InAI Civil Workflows. Catch you in the next explainer.